So this section talks about trigonometric identities, and it's probably one of the most, I don't know, I think it's one of the most fun sections, but it also is one of the most frustrating sections when you're first learning about it. And so I have attached in iTunes U a Trig Identities PDF, so you can go back and look at it if you need to while you're doing your homework. But basically, it's exactly what you see here. We have our reciprocal identities, which you already know. And I know we write them weird. I write them with this 1 over, but basically it's the idea that whatever this was, you're just going to flip it over to get that one. And then we have our quotient identities. Now these will be new to you. And these will actually be very handy to you. In fact, you'll want to look at quotient identities. It's one of the most common things that you'll use. And so what you see is if you have the tangent of an angle, you can rewrite that as the sine of that angle over the cosine of that angle. That's going to come in very, very useful. And since cotangent's the reciprocal of tangent, you can flip that over. Instead of sine over cosine, it'll be cosine over sine. And then here we have, oh, do you know, I think I'm supposed to actually talk about this a little bit more. So tangent, well, let's just look at sine. Okay, remember how sine is y over r and cosine is x over r? Well, remember how those denominators cancel? And so really, if you put sine over cosine, you really just get y over x, which is exactly what tangent is when we were learning about that. Tangent is y over x. So it makes sense to take sine and cosine and put it over each other to get tangent. Now the Pythagorean identities, these, I mean really these are going to be your most commonly used identities, especially this first one, where sine squared plus cosine squared equals 1. And that's going to be very, very useful for us, but let's just look at why that is. So if here's my angle, remember I have the opposite and the adjacent and the hypotenuse. So if I look at sine, sine would be the opposite over the hypotenuse, and we'll square that. And cosine would be the adjacent over the hypotenuse, and we square that. Okay? Now, if I back up a little bit and I look at this, this is a right triangle, so I could use the Pythagorean identity. And I could say that, remember, the two legs squared, so opposite squared plus the adjacent squared should equal the hypotenuse squared. And so really, if I take and I divide by the hypotenuse squared everywhere, then you're going to see that I have the opposite over the hypotenuse squared plus the adjacent over the hypotenuse squared equals, and it's supposed to equal 1, as you see, it's supposed to equal 1, and look at what this is. If I reduce that, I get 1. So ultimately, you get to use that sine squared plus cosine squared equals 1, which will be very useful for us. I think I've said that before even. 1 plus tangent squared equals secant squared. We'll use that quite a bit, but you might have to look back at your notes to see that. And then 1 plus cotangent squared equals cosecant squared will be another one that we use. So let's get So let's first just kind of attack what is an identity and why would we use it. So you guys already know that if you had the square root of x, you could rewrite that as x to the 1/2 power. So maybe we have something that we need to simplify. And so what I do is I say, well, I have the square root of x, so I'm going to simplify that to be x to the 1/2. So I just used an identity. I said instead of this, I'm going to write this. And that's the 6th power. And 1/2 times 6 would be 3, so we get x cubed. So we were able to simplify it by using the identity, by replacing it with what it's still equal to. It's still the same thing. It's these two things still equal each other, but it's just in a simpler form. So now here's what we have. I'm told that sine of theta equals 0.6. Now in the last section, we would have drawn a triangle and labeled our sides, but now we're going to try doing this using trig identities. So here's what you do. You identify first off, what do you know? You know sine. So I know sine. And then what are you trying to find? I'm trying to find cosine. So now I want to go back to my trig identities, and I want to look at all my trig identities and see if there's a trig identity that has just sine and cosine in it. You're going to find a lot that have other things also besides sine and cosine, but we just want one that has sine and cosine. Anything else means I have too many variables. And so what you'll see is that you have the Pythagorean identity sine squared plus cosine squared equals 1. That's the only one that has both sine and cosine in it and nothing else. And so now I'm going to replace what I know. I know that I have sine squared. By the way, I need to point something out. That squared part right there, what that means really is it's really sine of theta squared. But I can't write that without the parentheses. If I wrote it this way, that means that theta is being squared, and I want all of sine to be squared. And so what we do, instead of having to write the bubble all the time, we take that 2 and we put it above the n. Therefore, it's saying the whole function is being squared. So if I'm going to replace sine with 0.6, which is what I'm told it equals, I need to square that because sine is being squared in this identity. And so then I do my math. I get 0.36 plus cosine squared equals 1. Then I do my math, subtract 0.36. So then cosine squared equals, that would be 0.64. And then I'm going to square root both sides, and cosine theta equals 0.8. Alright, so now I know sine and cosine, so these I both know. And then my next problem tells me I want to figure out what tangent is. And so now I need to find an identity that has either just one of these in tangent, or it might have all three in tangent. And we have a couple different things we could go with. One thing that I think of right away is the quotient identity, where tangent equals sine over cosine. And so we replace sine with what it equals, 0.6, and I replace cosine with what it equals, 0.8, and that reduces to 3/4. So tangent of theta equals 3/4. So that's one thing that you could have to do in a problem, is you're given some kind of information, you're supposed to find other identity or other trig functions using the identities. Another thing that you might see is that you have to transform one side to equal the other side. Think of this like a road map, okay? You are here. What's in between to get you to here, okay? Now, if you have a map or you're giving someone directions, you only talk about from one direction. You don't go back and forth. For example, if I needed directions to get to Red Lake Falls, I am not going to say, well, you know, in Erskine, we're on Highway 59, and Red Lake Falls is on Highway 32. And so then when you're in Erskine again, you get on Highway 2. When you're in Red Lake Falls, you're on Highway 32 going south, and then when you're in Erskine, when you're on Highway 2, you're going to see where it turns to Highway 32, and then you'll meet up with Highway 32. That would just be really confusing, go back and forth. Same thing here. What I'm going to do is I'm just going to start with one thing. I'm starting with my complicated side. And then I'm going to do math, and I'm going to say that that equals something until, hopefully, as I work it out, I get it to equal 1 in the end. Okay? But I'm not going to talk about 1, and I can't be moving things over there or anything like that. Not my usual math stuff where I'm solving equations. I am just doing math until I get to 1. And so one of the biggest hints you could ever get in this problem is to change everything into sine and cosine. So if it's not already in terms of sine and cosine, a lot of times it'll help to turn it into sine and cosine. So here's what I mean. I'm going to rewrite secant as cosine because secant is reciprocal of cosine. So I can write it as 1 over cosine, because whenever you want to talk about a reciprocal, if you don't already have something to flip over, you can just say 1 over that, and that would represent the reciprocal. And now, so you have a cosine at top and a cosine at bottom. These cancel out. One cosine goes in each of them once. And so all those ones multiply together to give you 1. And there we just transformed one side to the other side. And a lot of times when you finish transforming or you finish verifying, you sign it off at the end. Most people will just make a little rectangle, but you can have your own little symbol if you want. You want to make a little heart or something, you can do that. So this will be the last problem that we do. Now, as I look at this problem, I know that the last time I talked to you about this, I said to turn things into sine and cosine, and it should help you. But I want to warn you that there are times where you don't want to do that, and this is one of them. And the way you know that is if there's other math that you can do that you can see, that's what you should do first, is do that math. And so what I see is I have 2 bubbles that can be multiplied together. So I'm going to do that. I'm going to FOIL it out, or I'm going to use the box. And also, I want to point out, whenever you do a problem like this, you should always start by writing down the side you're starting with. So I'm starting with the left side because that's a complicated side, and that's one of the things you should think about too, is you usually want to start with the complicated side. And so as I write this down, I'm not going to write equals 1, and I need to multiply these together. So if you use the box, go ahead and use it. If you don't use the box, go ahead and FOIL it out. But I will write down the box. So I've got secant theta plus tangent theta. And on this side I've got secant theta minus tangent theta. So I've got secant times secant, that's secant squared. And then here I have secant times tangent. And here I have again secant times tangent, only it's a negative tangent. Sorry, it's hard to see. And then on the right I have negative tangent squared. It's hard to see that negative. Okay, so now because I have a secant tangent and a minus secant tangent, they cancel out. And so then I have in the box secant squared minus tangent squared. Alright, now I've done the math. I can see. I'm looking at this going, oh, this looks a little bit scary. And so now what I want to do is, yes. This is like this can be a frustrating section, by the way, but hopefully by doing a lot of practice, it'll help you kind of see some of the tricks and some of the things you can try. So what I'm going to do is, if we look back at our trig identities, you're going to see there's a trig identity in there that says 1, oops, that's not a 1. It says 1 plus tangent squared equals secant squared. And so, since I have a secant squared up here, I'm going to replace that with 1 plus tangent squared. And then it's still a minus tangent squared. And so then if you look at this, I have a tangent squared minus tangent squared. They're going to cancel out, and I'm just left with a 1, which is exactly what I wanted. And so I will finish off this problem that I've accomplished it. So again, the moral of the story, a couple things that happened in this one. First off, I did the math that I could see. I had bubbles that I could multiply. And then after I did that, I was looking at this saying, you know what, I can replace secant squared with my identity. So you're looking back at your identity saying, can you replace anything? And because I replaced it, it canceled out. Now another way you could have done this is you could have turned these into sines and cosines and seen what happened. And maybe that would cancel it out too. It just depends on what you're willing to try and what you think of trying, I guess.